made of tremendous numbers of imperfect cells that are tremendously redundant, and each one of us, through our genes, or each species, has adapted to a particular ecological niche to do as well as it possibly can. And trying to compare how one species has adapted that niche, whether it's a mouse or a monkey, and try to compare it to humans, I think is fraught with particular difficulties. And I think it's pretty true that we don't see Alzheimer's disease in animals. The mouse models of Alzheimer's disease are really mouse models of a very specific genetic defect that is a very rare cause of Alzheimer's disease. And I think that we have to be very careful to understand what the mechanics of the Gompertz law are. And what they basically do is say that your body is not a machine, but is a complex organism that has to survive over long periods of time, and over a period of time, there are mistakes that develop. And as these mistakes accrue, you have progressively more and more chances of failing. So you get into something called failure theory with this. And when Scott was trying to distinguish parametric definitions of aging, I think you have to get in to look at the exact issue of where particular failures have occurred. Now, a thing like presbyopia, when you have animals, when you have early humans evolving, where rarely did anybody live to be more than 30 years old, it didn't matter what your vision was like when you got to be 45 or 50. Now we're exploring sort of a brave new world where people are living to an average age of 80 years old, remembering that in 1840, the average life expectancy was only 40 years old. We are really exploring a totally different area here, and the increase of Alzheimer's disease that we're seeing right now is going to be a tremendously